Wow, it really is almost breathtaking how fast generative AI is moving, isn't it? I mean, one day it's making cool pictures, the next it's writing code. It feels like it expands every single day.
It really does. And, that speed, that rapid progress, it brings this really critical need to understand the potential risks.
And to address them proactively, right, before they turn into actual problems out in the world.
Precisely. We need to be looking for those weaknesses now. Think of it like testing the emergency systems on a new plane before it ever takes off.
Yeah.
Rigorously.
That's a great analogy. And that's exactly what we're diving into today, this whole world of red teaming, specifically for AI.
Yeah.
We've got some really fascinating sources lined up. There's stuff from NIST's AREI initiative, which is super interesting on its own.
Mm-hmm.
Then there's this research paper, Atoxia, about targeting toxic answers in LLMs. Also a big GAO report on Gen AI development.
That GAO report is quite comprehensive.
Right. And a guide on red teaming from AIC Japan, a study with lessons from red teaming, like 100 different AI products.
100? Yeah. That's a lot of testing.
And even some real-world scenarios to look at. So quite a mix.
It is. And our goal today really is to pull out the key insights from all of that.
Yeah.
We want to give you a clear picture of what AI red teaming actually is.
Why it's so critical right now.
Exactly. Why it matters, the methods people use, who's involved, and how it actually helps build safer AI in practice.
Okay, let's start with NIST's AREA initiative then. That name keeps coming up. What's the core idea there, and why is evaluating AI safety such a big deal right now, according to them?
So AREA assessing risks and impacts of AI. It's basically a dedicated test bed. It's part of the NIST AI Innovation Laboratory.
Okay.
And what's really insightful, I think, is that AREA emphasizes that understanding the potential downsides, the impacts on people and society. It's not just some academic thing. It's fundamental to doing AI development responsibly.
So it's built into the process.
It has to be. AREA's goal is to develop the knowledge, the tools we need to make sure AI actually benefits everyone by testing it really thoroughly.
So AREA is actively putting AI through its paces to find those weak spots.
Exactly.
Yeah.
Yeah, they use this really smart multi-layered approach. They do, standard model testing. Does it work as expected?
The basics.
The basics. Then they do red teaming, actively trying to break it, mimicking attacks.
Okay.
And they even do field testing, seeing how it actually behaves and impacts things out in the real world.
Right.
The whole point is bringing together all these different views to make the AI systems stronger, more reliable.
And this all connects to that bigger idea of AI safety, right? We hear that term constantly.
It absolutely does. And that AIC Japan guide we mentioned, it gives a really helpful definition centered on humans.
How so?
Well, it emphasizes that AI success isn't just about how clever the AI is. It's about its positive impact and, crucially, preventing harm across key areas.
Like what kind of areas?
Things like physical and mental safety, fairness, making sure it works for everyone, strong privacy protection, security against hacks, and transparency so we can actually understand how these things work.
Okay, that makes sense.
And red teaming is a critical tool, really, for checking how well AI systems actually live up to those safety principles.
Got it. That sets a great foundation. So with ARI's focus and this AI safety framework in mind, how do we nail down the definition of red teaming when we talk about AI specifically?
Well, think of it like deliberately putting on an attacker's hat.
Okay.
In the AI context, red teaming means actively trying to find and exploit vulnerabilities in an AI system. You use the kinds of tactics, the techniques a real adversary might use.
So it's like penetration testing in cybersecurity?
Exactly like that, yeah. Very similar concept,
Yeah.
but it's tailored to the unique challenges you get with AI models and applications.
So who actually does this? Is it just the AI developers trying to find their own mistakes? Or is it broader?
Oh, it's definitely broader.
Yeah.
That GAO report highlights this well. Commercial developers often bring in a whole mix of experts.
Like who?
Well, cybersecurity specialists, obviously, people who know attack vectors.
Yeah.
But also experts in responsible AI development, people tuned into the ethical side. And importantly, subject matter experts from law, education, healthcare, depending on what the AI is for.
So domain-specific knowledge.
Absolutely. That multidisciplinary approach is really key to finding a wider range of risks. Things you might not think of, like autonomous replication or CBRN risks.
CBRN?
Yeah, chemical, biological, radiological, nuclear risks. Serious stuff. And also various cyber capabilities the AI might enable.
Okay, so it's a wide net. Now, that Atoxia paper you mentioned, it sounds like it describes a very specific, maybe even counterintuitive way to red team LLMs. What's different about their approach?
Yeah, Toxia is clever. What they do is essentially work backward.
Backward.
Instead of just trying to write tricky prompts to confuse the AI, Ataxia starts with a specific toxic answer they want the LLM to generate.
Okay.
Then he uses another AI model to generate both a user question and a misleading start to the LLM's answer, all designed to basically lure the target LLM into saying that harmful thing.
Huh. So it's like setting a very precise trap. You know exactly what bad output you're looking for, and you engineer the situation to see if you can make the AI produce it.
Exactly that. It uses reinforcement learning to train its own attacker model. And the reward for that attacker model is based on how likely the LLM being tested is to actually spit out that predefined toxic answer.
And does it work?
Apparently, yes. The researchers found this targeted approach was surprisingly good at finding specific safety gaps in different models, even powerful closed ones like GPT-4o, not just open source ones.
How does that compare to, say, more traditional ways people try to jailbreak LLMs?
Well, the paper compares it to methods like AdviPrompter. Those typically focus on refining toxic questions to make them better at getting harmful answers. Ataxia flips it.
Right, focuses on the answer first.
Exactly. By focusing on the target answer and then generating the question and the misleading opening, it aims to really boost the odds of getting that specific bad output. It's a much more targeted probe for particular weaknesses.
That sounds incredibly useful. A very precise tool for the toolkit. Okay, shifting slightly. The AIC Japan guide you mentioned goes into detail about roles and responsibilities on a red team. Who are the key players there?
Yeah, according to that guide, you basically have two main roles.
Yeah.
The attack planner or conductor and the AI system experts. It sort of formalizes that diverse expertise the GAO report mentioned.
Okay, so what does the attack planner do? The conductor?
That person's basically the leader, the strategist. They do the risk analysis, looking at the AI, how it's used. Then they work with the team to develop risk scenarios like what could go wrong.
Brainstorming threats.
Right. And from those risks, they design the actual attack scenarios. How would someone exploit this? They oversee the whole process, maybe using automated tools, maybe AI agents themselves to run the attacks.
Okay. And the AI system experts, what's their role?
They're the ones with the deep technical knowledge of the system being tested.
The insiders, maybe?
Could be. They understand the architecture, the specific LLMs used, any external tools or libraries it connects to, the security measures already in place. The attack planner really relies on their technical input to define the scope correctly and make the attacks realistic and effective.
The guide also talks about collaboration beyond the red team, right? Who else needs to be involved?
Oh, absolutely crucial. The attack planner needs to work really closely with the main project team, the people building and deploying the AI.
Makes sense. So the findings actually get used.
Exactly.
Yeah.
And for AI in high-stakes areas, think healthcare, finance, you absolutely need domain experts involved. Doctors, lawyers, whoever understands the specific risks in that field.
Right.
The guide also points out, you need proper organizational support. Investment. It's not just a side project. It needs backing to be effective.
So it's not just technical. It needs that organizational buy-in. Okay, let's talk about the actual process. The AISI Japan guide lays out steps. Can you walk us through that generally?
It's quite methodical. It starts, obviously, with deciding to actually do red teaming. Ideally, that comes from the dev or security teams with leadership support.
Okay, step one, decide to do it.
Right. Then the critical next step is getting a really deep understanding of the target AI system, its design, how LLMs are used, what external stuff it touches, what defenses it already has.
That sounds like a lot of homework up front.
It is, but it's fundamental. You need that to define the scope properly. Are you doing black box testing, acting like an outsider with no internal knowledge?
Okay.
Or white box where you have full access?
Right.
Or maybe gray box, something in between. The scope also covers the testing environment and having a clear plan for what to do if you find something really serious, escalation flow.
Got it. So understand the system, define the scope. What's next?
Then you develop the risk scenarios, brainstorming potential threats based on everything you've learned, architecture, AI safety aspects, what data it handles, how people use it.
Thinking like the bad guy.
Pretty much. And once you have those risks, you develop specific attack scenarios, detailing exactly how an attacker might try to exploit those risks. This often takes some creative thinking.
And then the team actually tries the attacks.
Precisely. They execute the attacks based on the scenarios, keeping meticulous records of everything they do and find.
Documentation is key.
Absolutely. Then comes the post-attack phase. analyzing the results, writing up a detailed report on the vulnerabilities, and then this is critical, developing and implementing plans to fix those weaknesses.
Closing the loop.
Right. And the guide stresses red teaming isn't a one-and-done thing, especially after release. It needs to be ongoing, iterative, because threats are always evolving.
You mentioned different attack methods earlier. What are some key techniques red teams use, especially for large language models?
Well, one of the big ones, really relevant for LLMs, is prompt injection. Both the AISI Japan guide and that airteamscenarios.pdf source highlight this one.
Okay, prompt injection. How does that work?
It involves crafting input prompts very carefully to make the LLM do things it shouldn't generate harmful content, ignore previous instructions, things like that.
And that can be direct, like just typing in a malicious prompt.
Yeah, that's direct injection. But it can also be indirect. An attacker might poison external data sources that the LLM uses, maybe through Retrieval Augmented Generation, RAG.
So if the LLM pulls in outside info, that info could be compromised.
Exactly.
Can you give us an example, make it concrete?
Sure. That airteamscenarios.pdf has a great one with Microsoft Copilot. An attacker sends an email with fake bank details for a transfer.
Okay.
Copilot's RAG feature indexes that email, thinking it's legit info. Then, using prompt injection, the attacker tricks Copilot into presenting their fake bank details as if they were from a trusted retrieved document, maybe even messing with the citation.
Wow.
So a user might see that and think the attacker's details are correct, and then, well, you can imagine the financial risk.
Yeah, that's a powerful and frankly scary example of how these vulnerabilities can have real consequences. Are there other attacks red teams look for beyond prompt injection?
Yes, the AISI Japan guide mentions others used against AI more broadly. Things like poisoning attacks, messing with the training data itself.
Right.
Adversarial attacks, creating inputs that look normal to humans but fool the AI. Model extraction, trying to steal the model. Yeah. Membership inference, figuring out if specific data was used in training. Model inversion, trying to reconstruct sensitive training data.
Okay, a whole range.
Yeah. Their effectiveness against LLMs specifically is still being actively researched in some cases, but they're on the radar. The guide also points to the Mitrailleles framework as a good resource for getting a handle on all these different AI attack techniques.
It really sounds like a constantly moving target. New attacks, new defenses all the time. Now, that other source, the one with lessons from red teaming 100 different Gen AI products, any key takeaways or recurring themes from that huge effort?
Yeah, one case study really stuck out to me. It highlighted a really crucial aspect of safety.
What was it?
It involved testing how a chatbot responded to a user showing signs of serious emotional distress, saying they felt depressed, maybe even having thoughts of self-harm.
Oh, wow. That's sensitive.
Extremely. And the red teaming found significant weaknesses in the LLM's safety training for that kind of situation. The chatbot's responses were sometimes inadequate, sometimes inappropriate, potentially even harmful to someone's mental state.
That's sobering.
It really is. And it underscores that AI safety isn't just about stopping hackers. It's also about ensuring these systems are genuinely helpful, or at least do no harm, in all kinds of interactions, especially sensitive ones.
That's a critical point. The scope is much wider than just security flaws. So ultimately, what's the big picture goal here? What's the point of all this AI red teaming effort?
Well, the bottom line is building safer, more reliable, and ultimately more trustworthy generative AI. That's the goal.
Makes sense.
By proactively finding these potential problems, these vulnerabilities, by simulating real attacks, developers can then build in the right fixes, the right mitigations. It improves the robustness before these systems are widely deployed and potentially cause real harm. It's essential for building confidence.
Yeah.
And actually, speaking of support, we'd like to thank our sponsor, www.cisomarketplace.com, for helping us dive into such a critical topic today.
Okay, so let's try to wrap this up. In this deep dive, we've really looked at how the incredible rise of generative AI means we absolutely have to focus on safety proactively. We've examined AI red teaming as this vital process for finding vulnerabilities by essentially thinking like an attacker. We talked about NIST's area initiative, the broader AI safety principles.
Yep, frameworks.
We got into specific methods like ataxia, that novel way of targeting toxic outputs in LLMs. We outlined the roles, the systematic process from the AI Japan guide, looked at attacks like prompt injection with real examples.
And those important lessons from testing many different products, highlighting the broad scope of safety.
Exactly. It's clear that as AI keeps advancing at this incredible pace, our red teaming strategies, our safety approaches, They just have to keep evolving right alongside it.
Absolutely. And that really leads to a final thought, maybe a question for you, our listener. How can we, as individuals, as organizations, actively participate in making these AI systems safer and more resilient in our daily lives and our work? How can we contribute beyond just relying on the developers?
That's a great question to ponder.
Yeah. We definitely encourage you to check out the resources we discussed, NIST area, that Ataxia paper, the GAO report, the AI Japan guide. Dig deeper, expand your understanding, and think about how you can play a part in this really important effort.